Welcome to again electrical machine practical. We have a one practical reversal of a DC shunt motor and study of 3-point starter. So first of all we see the what is the meaning of reversal of direction. In many application we need to change the direction of motor, or we have to change the direction of rotation of motor. For example, crane, we have to lift the some material, so there is a one direction. Then when we are hauling the material, then there is a second direction. Similarly, some cranes are there which is mounted in the machine shop, which will move x and y means through forward direction and backward direction. Again it will lift some material, so the motor direction of rotation has to be changed with the application, isn't it? So in the case of DC motor, we are it is very quite simple to change the direction of rotation. Now see here, this is the our 3-point starter. We will take the detail of 3-point starter, no doubt. So first of all we will consider the connection, normal connection. In the normal connection, positive terminal is connected to the ammeter. Ammeter is connected to the line of the starter. Armature terminal A is connected to A1, F is connected to F1, and whereas F2, A2 both are connected to the negative term. So this is say the normal connection of the motor, and it will give the normal direction. Now we will see what is the direction of rotation. So when we switch on the supply, we will observe the direction of rotation. Here the some marking is carried out. So you have to remember the direction of rotation over there. Okay. So this is the direction is clockwise. The rotation of the motor is a clockwise, so it is a clockwise direction. We will assume that the direction is normal. Now for some particular application we want to change the direction of rotation. So how to change? There are two methods. Either we can change the direction of current in the armature, or we can change the direction of current in the field winding. But if you do the simultaneous change in the current in armature as well as the field winding, the direction does not vary. So you have to change only the current in any one of the element, either in the armature terminal or either in the field terminal. Now first we will try to change the direction of rotation by changing the armature terminal. Now A is connected to A1, so we will connect, instead of A1 we will connect to A2, and A2 is connected, the terminal of A2 earlier it is connected to A1 and A is connected to A2. So now suppose earlier case the current in this direction is downward for our understanding purpose. Now the current coming from here and it goes to the opposite, whereas the current in the field winding F to F1, F1 to F2, whereas in the armature winding it is A2 to F1. So here the direction of current has been changed in one field. Now we will see what is the direction of rotation. Either it is a previous case, same direction, or reverse. In the previous case, in the normal case, the direction is clockwise. Now see, the direction is anti-clockwise. The meaning is that the direction of rotation is changed or can be changed by changing the direction of current in the armature winding. Now what we will do? We will change the direction of current, direction of rotation by field method. So we will connect the armature in the normal position, means A is connected to A1, A is connected to A1, and A2 is directly connected to the negative. So this become our normal connection which we have done earlier case. Now we are going to change the direction of current in the field winding. So this is the, here we have changed. Here now F is connected to F2 and F1 is connected to the negative. So here the direction of current in the field winding is get changed. Now what is our expectation? Our expectation is that the direction of rotation should be anti-clockwise, because we have assumed that the clockwise direction is the normal direction. Now see here, again the direction of rotation is opposite, that is the anti-clockwise. So our conclusion is that we can change the direction of rotation of the DC shunt motor either by changing the current direction in the armature or by changing the current direction in field winding. So by these two way we are able to change the direction of rotation. But which is the good method? We know that the armature carries heavy current because it will handle the load current, whereas the field current is smaller in the range of 3 to 5 ampere is there even for the big machine, and for a small motor it is hardly 1 ampere or less than 1 ampere. So it is quite clear, quite easy to change the direction of current in the field winding because it does not produce the heavy sparking, and which will lead to the low maintenance. So most of the time, for most of the application, we want to change the direction of rotation, especially for the lift, crane, hoist, and many applications are there where we are going to change the direction of rotation of motor. So we can easily change the direction of rotation of motor either by field method, either by armature method. Pause.